There is a sharp distinction in scientific research between knowing that an event will happen and understanding exactly why it occurs. Consider this historical data correlation. By tracking the lengths of women's skirts, early analysts found they could perfectly predict the rising and falling of the stock market. As hemlines rose during periods of economic boom and fell during recessions, the two datasets moved in synchronization. Or take an even stranger correlation. Tracking the temperature of the sidewalks in Madison, Wisconsin, allowed researchers to predict the exact birth rate, nearly 4,000 miles away in Oslo, Norway. These are what philosophers of science call accidental generalizations. They provide a high degree of predictive accuracy, but they contain zero explanatory power, because no physical or economic mechanism connects the variables. In 1965, Carl Hempel proposed the structural symmetry thesis to codify this relationship.
He argued that explanation and prediction are perfectly symmetrical. This equation illustrates Hempel's initial thesis. Every adequate explanation implies a potential prediction, and every accurate prediction acts as a potential explanation. But only the first half of that equation holds true. While explaining a phenomenon allows you to deduce the conditions to predict it, the inverse is false. Accurate predictions can be made using purely accidental generalizations, like predicting stock markets with skirts, leaving the observer with no scientific insight into the cause. A predictive data model that lacks a theoretical causal architecture leaves you blindly guessing why your market behaves the way it does. This brings us to a concept known as Dubin's power paradox. Robert Dubin argued that certain social science theories are valuable because they offer profound understanding, even if they completely lack predictive precision. The logic behind this paradox collapses upon inspection. Since understanding requires a valid explanation, and every valid explanation must generate predictions, a model that cannot predict cannot explain. Therefore, true scientific understanding explicitly demands predictive capacity. You cannot claim to understand a consumer behavior if your framework cannot forecast when that behavior will occur. This predictive requirement differs from another analytical tool, retrodiction. Prediction forecasts the future from present observations, while retrodiction decodes the past from those same present observations. Think of carbon-14 dating. By measuring the radioactive decay inside a specimen today, a researcher can calculate the exact century an organism died. Carbon dating relies on necessary conditions. It proved the organism had to die for this specific decay to exist. Prediction, conversely, requires sufficient conditions, identifying the exact variables that will trigger a specific future outcome. Marketing models achieve strategic utility by mapping these sufficient conditions for future success, moving beyond the mere decoding of past failures. To build those sufficient conditions, we have to move past simple correlations and prove causality. We need a specific mechanical linkage between two events. Philosopher J.L. Mackie defined this linkage using the INUS condition, identifying an element that is an insufficient but necessary part of an unnecessary but sufficient framework. This logic gate diagram maps the INUS framework. To reach a final output, several specific conditions must align. Take the claim that a high-end brand image causes consumers to perceive high quality. Under Mackie's framework, brand image alone is insufficient. A consumer still has to notice the product, evaluate it, and actually need it. As the diagram shows, pushing the brand image input without the other variables fails to trigger the final purchase decision. But when routed correctly, brand image becomes a necessary pathway within a broader, sufficient sequence that finally drives the quality perception. To systematically verify these causal links, researcher Shelby established 4 criteria. The first is temporal sequentiality. The cause must objectively precede the effect. The second is associative variation. The variables must empirically move together. The third is nonspurious association, meaning no hidden third variable is secretly driving both effects. The fourth is theoretical support. The relationship must align with established scientific knowledge. This is exactly why the hemline and stock market correlation fails. Even though the data moved together sequentially, no established economic theory supports the idea that tailoring choices dictate global financial markets. When modern algorithms spit out high-probability market correlations without INUS-grounded theoretical support, strategists execute campaigns based on statistical ghosts. Even when we do establish solid causal links, we face the problem of the infinite regress. Every explanation is built on previous explanations, meaning all theories are technically incomplete if you dig deep enough. In consumer research, we often see shallow explanatory chains. A classic progression assumes that consumer attitude dictates preference, which drives intention, which finally results in behavior. This node graph shows the linear sequence. It's clean but stops short of explaining why the initial attitude formed. Expanding to a multi-attribute model, the graph deepens into a web of product traits, social pressures, and economic constraints that built that attitude. The depth of your explanatory chain dictates your precision. If you only know that preference drives intent, you can only observe. If you know the exact attributes driving preference, you can intervene. When chains are too shallow, they often become enthymums, elliptical explanations that silently skip over the necessary laws required to make them true. These skipped steps result in explanation sketches. They are highly useful heuristic maps for discovering new hypotheses, but they lack the rigorous logical architecture required for scientific proof. To map the market accurately, deep chains must address 4 fundamental explananda: why buyers behave as they do, why sellers behave as they do, how institutions form, and how society responds. Identifying these hidden enthymums provides a structural audit, verifying whether a marketing plan rests on scientific laws or merely an incomplete sketch. If we apply this rigorous standard to classical marketing theory, several famous frameworks begin to fracture. Take the product lifecycle. It posits that every product moves through distinct stages: introduction, growth, maturity, and decline, each requiring different marketing tactics. This standard bell curve illustrates the lifecycle, but notice how it loops. We define a product's stage by observing its sales volume, and then we use that stage to explain its sales volume. This creates a tautology. It is purely analytic and true by definition alone. Because it lacks external, testable variables, it has no empirical content and zero explanatory power. Or look at the EKB model for consumer choice, which details the evaluative criteria buyers use to select an item off a shelf. A shopper evaluates price, scent, and brand familiarity, processes these criteria, and then makes a purchase. The model assumes the criteria cause the purchase. However, empirical studies often show the exact reverse. Consumers buy a product out of habit and then adjust their evaluative criteria to justify the purchase, failing the temporal sequentiality test. Building a campaign around a canonical model that gets the sequence of cause and effect completely backward is a fast track to market failure. To see what a structurally sound explanation looks like, we can examine Julian Simon's model regarding price discrimination in media advertising. Compare that to the wheel of retailing, which observes that new retail formats, like the emergence of budget motels, always enter the market as low-cost operators before slowly upgrading their facilities and raising prices. Just like this roulette wheel, the theory observes a repeating pattern, but stalls out. It offers no causal mechanism explaining why the wheel turns. It is an explanation sketch. It describes the historical pattern of budget motels without explaining the economic forces that force them to upgrade. The theory is only completed when we integrate Clark and Alderson's concept of differential advantage, showing that retailers are forced to upgrade to outmaneuver new competitors entering the low-cost space they just vacated. This is the dividing line between observation and science. A competitive advantage isn't found by merely predicting what the market will do next. It is secured by building the exact causal architecture that dictates why it has no choice but to do so.